Thank you for joining us today. I'd like to share with you how to have the deep dive Windows containers on Kubernetes. Allow me to introduce myself. My name is Pengfei, come from Microsoft, and I'm also a maintainer of the Kubernetes. Now in Ada, I'm responsible for the Kubernetes, and I'm responsible for secondary and second nodes and other important things. I have 3 parts to cover. Number 1, Windows containers. Number 2, how to manage containers. Number 3, the future development. Now let's move on to the first part. When it comes to containers, I know that all of you are very familiar with the Linux container. It is a virtualization technology for the OS, and it can operate with the shared kernel. In terms of a Windows container, can also be run with a mode of shared kernel, and it can be run on the Windows service, and also can run on the machine with a way of virtualization. We know that on various kinds of platforms there are the virtualization technology, and we know that there are 2 ways of virtualization. With container, it brings a lot of benefits to us. For different people, we see different advantages. For developers, we see it's agile delivery and faster iteration, but for the IT engineers, they focus on the cost savings and elastic bursting, so as to tackle with some bursting events. For the container, inside the container, for the Linux container, it contains 2 parts. One is basic image, and the other is application. For the Windows, it's the same case. For the basic image, it has its install registration point and its storage and its library. If it is runs on the web server, and must rely on the .NET framework. In order to compose such a container, we must use the stock file to use the basic image to describe it, to describe the composition. So this is the simple example. You see, here is the basic image, is the Windows Service Call, and here is you can install a web server. With the command, you can define its demand with default with a Docker command. You can make it like a option, and you can run this container on Windows. It is different from Linux containers. Like there is a Ubuntu and a lot of other basic image, but for the Windows, the base images and have several types. For the Windows item, you see here are all the options. There were 4 kinds here. You see that the first 3 are used for growing environment, and the last one is for development. You need a nano server. It is minimal. It's a minimal one, and includes the .com. It is designated for the cloud. The second one, Windows Server Core, it includes the full .NET framework support. So you see, here it can be run on the .NET Windows application. But actually, this, if you want to do the UI library, and this must be used on the Windows. You see, on the Windows vast majority of functions, if you want to do the UI design, you must use the Windows option. For the first 3 ones, if you use a Windows Server Insider, you need Insider item. So these are used for testing. These are stored on the .hub, but now we put it on MCM. So for the new one, we can use this CM. Maybe it's not very clear. Could you just turn off the light? So as we can see the slides clearly. When the container runs, actually the structure of the container is different. It's similar to the Linux, and it depends on the layers the management. The first layer is a readable layer, and you can see the several layers. And according to the .file definition, this is a simple example. You can see that the last part here is all kinds of layers. If we go into each layer, you can see each layer matches each file, and they're different. When the containers run, you see, use the doc run, we can run this container. When it runs, it is similar to the Linux. Actually, it's different in terms of realization. We can run C and Linux and this namespace isolation to run this container, but on the Windows, we don't have the run C. With the host computer service and host net service, with these two services, it manages the container in terms of running and network. For Windows container, compared to Linux, it supports different kinds of models of isolation. You see here are two, and you can see them on the slide. And it's similar to the Windows, similar to the Linux. But for the other isolation model, and there are some differences. If you have the kernel configuration, it will not affect the host. And next one would be the Windows Server versions. For the Windows Server, here is the involvement of Windows Server. For the Windows container, we started from Windows Server 2016. It supports the most basic containers. With Docker EE, this container can be managed well, but it can also use Windows 10 Docker WinRAR. And after that, it's a 709, 1803, 2019. So you see this server's version has been improved a lot in terms of the network capability and the performance. And when we moved on to the Windows Server 2019, the Kuma base and all of the performances are improved. The 2016 and 2019, they are the most commonly used. And for the first and the fourth, but you can upgrade 2016 to 2019. You cannot upgrade 2016 to 1709. So that's the difference. So the 2016 and 2019, and they are the commonly used. For the 709 and 1803, they are designated for the new ones with the new functions and features. For the Windows server, Windows container, when they run, they must match with the Windows Server version. If they match as well, and we use the two models of isolation model. If the Windows Server's version is higher, you can only use the Hyper-V to run this container. So we must do it in this way. When you run the container, you must pay attention to the versions matching problems. After introduction of the containers, let's talk about the Kubernetes on Windows Server. We talk about that Docker can run a container, but it's not enough. Actually, when a container is run, we must manage it well, like the scheduling or the service discovery or the fault fixed. So for all of this, a single container cannot manage all of them. For the Kubernetes, they can solve all of these kinds of problems. For the Kubernetes features, you are very familiar with them. Now let's look at the structure of Kubernetes. And this is similar to the Linux structure. It has a master node and a work node. For the node, it runs the kubedoxy. But for the Windows, it's the same. But actually, the node is transferred into Windows Server. The kubelet is turned into the ESD so that it can be run on the Windows. It's a binary. For the Windows Server, and this is a development of the Kubernetes on Windows Server. It starts from Windows Server 2016 and supports a Windows container and develop a. You see here, and it developed in 2017 in Kubernetes. We added the basic support for the Kubernetes container, and when it comes to 2019, for the Windows features, it strengthens all of the kinds of features. And when it comes to 2019, we have released the beta support, and until now, the Kubernetes have released 1.12 version, and now we have the 1.13 version. So for these middle versions, and they have strengthened the Windows specifications. And you see for the core, the features released, and they can be introduced into Kubernetes. And for the next version, the 1.13 version, and we will have it matched with the container. And here is the core features of Windows container. Number one, it is a version. When it's 1.13, we have the several versions you can see on the slide. And it can support the Linux network space isolation. Different containers run on different network namespace. It can also support the service discovery and load balancing. And in the meanwhile, it supports CLI in order to manage the container runtime or the CRI, and also has support the storage plugin. And compared to Linux container, it supports a lot of isolation models. When we set up the cluster with this container, it is different from the previous approach. For the master nodes, it cannot operate on Windows Server. So when we set up this clustering for the master nodes, it must be run on the Linux. So within your clustering, there are a lot of Linux nodes, and there are some Windows nodes. For the Linux and Windows nodes, and they can be mixed together in one cluster. You can manage it. When you do the scheduling, according to the pod strategy, like you can choose different nodes. When set up the clustering, the most important thing is to provide the network storage for the container and all other functionalities. And you see here, this is the network plugin. For the Windows, we can with the CII to use the community and your self-developed network plugins. You can use NetCI, and you can make it inserted with your virtualized network. And you can in other places use the OpenWay Switch and Flannel and other plugin or the Kali code, or you can use the simple WinCI. it's a simple breaking plugin, also like Kubernetes plugin. So it's a simple way of doing the practice on the network. So I'll give you an example with a WinCI, and it's a topology structure, and it's with the Kubernetes network. It's a similar scenario. On each node, we assign a IP address for all the containers. It can get a IP address, and with the network bridge, they can be linked together.
For the cross-node communication, we have a router. For example, you can see on the lower right corner, we have a router table, and this can be run on this platform. And also, we can finish this config. If you have the physical machine, it could be configured into the exchange machine. In terms of storage, for the Windows, we also support for lots of plugins. For example, in the repo, we have the host path, Azure file, or Azure disk. You can directly use them in Windows. And if this machine cannot fit for all your needs, then you can go through Flex Volume to develop the external plugins of WinPo. And now you can have lots of options, including Key Vault, Blob Fuse, or SMB. So all of these plugins can be implemented through Flex Volume. And also now in the Kubernetes community, we are now promoting the working in process. And CSI now support Linux. We have the beta version, but for Windows, CSI currently does not support. And CSI provides lots of auxiliary containers. The containers can only run on Linux. And now we're also working on the CSI. I have shared with you a lot. So how to run the Windows container? Let's take two examples. One is pod, another is a daemon set. For pod, you can see here this is a config of pod, very similar to Linux, but the image needs to be changed to the Windows image. For example, here we have Windows Service Card 1709. So in the scheduling, you need to think that you can put this on the Windows node. And finally, we have a node selector. So to put it on the Windows node, for the daemon set, similar to the pod, the image, you need to have the node selector to put the container on the Windows node. And if in your cluster you have the Linux applications, then actually you need also limit these applications. For example, in this cluster, you need to set its OS. You can only put this on the Linux node. If you put this on the Windows, then the Linux cannot run. We have lots of known issues in terms of limitations of running the Windows containers. First of all, for the multiple containers pod, this is very common actually. We need Windows Server 1709 or the later version. If you use the previous versions, then this cannot run. And also we have discussed two isolations, including Hyper-V. Now Hyper-V only support for one pod, single pod. If you have multiple pod, you have to go through the server 1709 or the later versions. You cannot use Hyper-V for isolation. Second, I have shown you the container and its matching to these windows. And they have to maintain at the same version, and to have the process isolation. And also the Windows Container OS must match the host OS. Another issue is the DNS config. The DS config is done through the plugins. For the Linux, it has etc resolve file and can finish config. But we don't have this file for Windows, so you need plugins for Windows. And for Windows containers, lots of storage plugins are not supported. We are figuring out some more ways to improve the files that we can support. And also, we have mentioned about Wave. Well, actually, Wave cannot run on Windows. And the Chronicle plugin only supports parts of the functions. And last issue, in terms of load balance, it also has some limits. The local traffic policy is not yet supported. This local traffic policy needs to maintain its original IP, and is not supported now on the Windows. It needs the higher level version. So in the second part, I have discussed with you about on Windows how to manage the containers by using the Kubernetes. The third part in my presentation is about the following up steps. So we have a Kubernetes community, and in the future, what about the support for the Kubernetes on Windows? So first of all, we have 1.13 version, the Windows Server 2019 will formally support it. And several days before, we have just released the latest version of 2019, so now you can access this. And also for the storage plugins, we will support more. In terms of flex volumes, SMB, CSI are supported, but CSI is not completely ready, so the support for CSI cannot be included. Also, now in our community, the container interface, like container J, will be supported by Alpha. So you can use CI to run container D to manage the Windows container. In the future, more features will be included. So these new features will be run in the runtime of container D, and then will be included in the other parts. And also, if you want to have a very stable version, then test would be very important for you. And we are now conducting the series of tests to validate different cases and different functions. We have to make sure that the tests cannot accept it, especially the conformance test and node E2E test, end-to-end test. It means that for the single end, we need to validate its functions. For the future development of the Windows on containers, we also have our thoughts. First of all, we know that on Windows, it is supported Linux. On Windows Server or Windows 10, you can use it to run Linux containers. So in the future, on Kubernetes, we can also go through this way, through the Kubernetes API to manage the Linux containers. As I mentioned before, we have the API server. It cannot run on Windows, but in the future, we can go through this way to use the Linux container to run them on the Windows container. And in the future, you just need Windows container. You don't need Linux node to manage this matter, and all this can run on the same Windows server. The second is for container D. As I mentioned before, container D will involve lots of new features. So these new features will go through container D first. And for these new features, first of all, they will run within container D and integrated into container D. And we probably will take container D as a default runtime instead of Docker, because the release cycle of Docker is even longer than container D. Also, in terms of storage plugins, especially CSI, in the future, we will also configure the Windows container targeted auxiliary containers to support for more plugins, especially the frequently used CSIs, the plugins, including CSI. I also mentioned about the isolation for Hyper-V. Now it only supports for the single pod, which means in one pod you can only run one container, and in the future it will support the multi-pod, the same to the process isolation. Some pod will use the container or use the multi-container scenario. And for this feature, probably will be supported in Container D runtime. In the next phase, with the release of Docker, this will be evolving to the Docker. So we'll put this in Container D first. And lastly, for daemon set, actually now we have a lot of the plugins, including network and the storage plugins are deployed by the daemon set. But now Windows cannot support this because Windows does not have this privilege mode, which means that if you want to configure the host features, now this is very challenging. So in the future, we will support to use the containers to configure the host containers and use daemon set for management. Similar to Linux containers, the privileged containers can change the files and configs in host. So these are some references that you can take a look for Windows containers. As I mentioned before, it has lots of differences to Linux, and in the building, the basic working rationale of Windows is different to Linux. And if you come across lots of difficulties or the problems, questions, you can refer to all these files. For example, if you want to set up a Windows node, so first of all, you need to have a master Linux. And then for the Linux Windows server, how you can set up the Docker, etc. So this file would be very helpful. And this is a kind of the virtualization website by Microsoft. And also on Kubernetes official website, they also have a very professional starting up guide. And we're keeping optimizing this file in the future. Well, now we just put all this information separately on different websites, and in the future we'll try to optimize this and to give you more details. For Windows containers, we have a lot of the resources relying on Windows Server, so lots of features need support of Windows Server, and to implement on Windows servers. So here, Microsoft has its blogs to introduce to you the new features brought by the containers. And also you can find lots of the videos from YouTube here. In terms of the network plugins or configs, we don't have a daemon set to help you deploy this plugin. So when you deploy the plugin, first of all, you also need to refer to these files for the config. So this is Microsoft SDN configuration guidance. And for this topic, the config, my colleague, Danish, will provide you more details about the implementation on the internet. And if you care about the future roadmap of this Microsoft container development, you can go through this file. And this will tell you the Windows container and the Kubernetes integration, its feature list, and the current bugs, the current vulnerabilities under fixing. So this is my sharing with you today. I still have 5 minutes left. If you have any questions, you can raise your questions now. Microphone, please. So you mean about the collection monitoring of logs, right? The agent. If you use Fluentd, it will not support. As far as I know, open sourcing community does not have very sound means to support it. But if you use a public cloud community platform, then they can support it. It offers the very fundamental features. For example, Asia has the Asia Monitor, a monitoring plan. Within this plan, they have lots of solutions to help you to support for all these monitoring containers. And in Asia, this is OMS, Operation Management System.
Use the microphone. Yes. For the monitoring, there is two parts. One is for the container logging collection, the other is for the analysis and the monitoring system and also demonstration system. And I think you have to collect the metrics like the CPU and the memory and the resources collection, those here. So that's my answer. Thank you. For the local containers and the cloud containers, sorry, use the microphone. Actually, for the local container to the cloud container transfer, actually it's similar. As long as you can make it a doc image, you can put this doc image on any place. But actually, you have to focus on the Windows Server version and also other versions. These versions must be matched with each other. And maybe you can use a Hyperbait to run it. It's okay. Use a microphone. The interpreter cannot hear the voice. I can show an example for you. It stores according to the layers. The Windows layer is similar to Linux layer, but actually for the Windows, for the FX type is different from Linux. I don't know whether list scanning tool you will use, but actually they support in terms of the principle. Here's a simple demonstration. According to the Docker API, you can check the list. With the Docker inspector, you can check the gross driver and its relevant layer, and you can also see the file that includes the layers and the other catalog, and with just a file description. And here is an example. When they say 1.13 GA, what is the network like? For all of these network plugins, they can be supported. And here is the list. And I can just wait a second for the next session, and I will relate it to the Windows Network detailed introduction. And for this part, you see all of these kinds of network plugins can be used for the Calio. It is not totally supported, and it cannot be put on the system. If we use so the containers can be communicated with each other. You see, for all these listed plugins, if you deploy a cluster, and this network must include the cluster, it includes the Linux node and the master node for the Azure CI. It can be used on the Windows and for the Windows APX. And you must be very familiar with that. For the Flano, you know that. For the WinCI, can only be used on the Windows. When it is used, you must have the Linux plugin like the Kubernetes, the default plugin for the Calico. It can only support the polycene mode, so it must have other plugin to make it work. And it can have this the Calico with the WinCI, so as to set up a comprehensive cluster. I have another question. If the Windows container can the Windows container use it? which part will provide the node or the metrics? For the metrics, for the C advisor, it's as a Kubernetes inner function. It provides API for the Windows with the Kubernetes CPI, and it provides it outside. Inside the Kubernetes, there's no C advisor, but actually it has the relevant implementation, and like the VPI, and it can get the similar data of the Linux, like the file system, the CPU. For the C advisor, if it adapts to the Prometheus. But now if you adjust the API, no, it's not the Docker API. This API are the standard Kubernetes API. So when you use it, and it can support the Kubernetes metrics endpoint. I remember previously I deployed this, and I can collect all of these kinds of data I just mentioned. Thank you. And I think that's all from my part. Thank you.